In the first half of the 20th century, the agricultural landscapes of the United States and Germany evolved under very different conditions. These environments shaped distinct engineering philosophies that would eventually collide in an unexpected comparison. The trusted German-built Fendt tractors versus the American-built John Deere D, a machine whose endurance would challenge long-held assumptions about reliability. German farmers valued mechanical precision. Post-war agriculture in regions such as Bavaria, Baden-Württemberg, and Hesse relied on machines that needed to operate efficiently on smaller parcels of land, often with uneven terrain and mixed soil profiles. Manufacturers like Fendt responded with compact designs, efficient diesel engines, and carefully engineered transmissions optimized for low-speed control. These tractors emphasized fuel economy, traction stability, and a balance between weight and power that suited European farming patterns. By contrast, American agriculture was defined by scale. The expanding farms of Iowa, Nebraska, Kansas, and the Dakotas demanded machinery that could work uninterrupted across large fields for many hours at a time. In that environment, endurance mattered more than refinement, and simple mechanical systems were often preferred over sophisticated ones. When John Deere introduced the Model D in 1923, the tractor embodied this principle. A robust, straightforward design with an engine built to handle long operational hours without complicated maintenance. The two engineering cultures rarely intersected in a direct, practical comparison. German assessments of American machinery often assumed that U.S. tractors were too heavy, too primitive, or inefficient for European standards. Meanwhile, American farmers viewed European diesel technology as overly complex for the wide-open conditions of the Midwest. But the introduction of used American tractors into European markets after the war began to challenge these perceptions, especially as some of these older machines continued to operate with surprising resilience. At the center of this contrast stood the John Deere D. The tractor used a large two-cylinder engine known for its extremely low-end torque and consistent combustion cycle. Its mechanical layout was uncomplicated: minimal electrical components, a simple lubrication system, and a heavy cast-iron chassis designed to absorb stress during prolonged work. The tractor did not aim to deliver sophisticated control. Its strength lay in surviving conditions that pushed many other machines to failure. This created an unexpected point of comparison with Fendt machines of the same era. Fendt designs prioritized efficiency, precision gear ratios, responsive steering geometry, and fuel systems calibrated for controlled output. German farmers trusted this approach because it aligned with their agricultural demands and engineering expectations. The appearance of the John Deere D, an older and visually rugged tractor, did not fit their established understanding of what a reliable machine should be. Yet the Deere's simplicity proved to be its most defining strength. In many European environments, the tractor operated for extended periods with minimal adjustment. It tolerated lower-grade fuels, inconsistent lubrication routines, and variable soil density. While Fendt machines excelled in precision and efficient operation, the Deere demonstrated an endurance that surprised farmers who initially underestimated it. By the end of this period, the contrast between the two tractors revealed more than mechanical differences. It represented two philosophies: refinement versus durability, controlled engineering versus operational resilience. The John Deere D stood as an example of how American agricultural machinery could perform in environments far removed from its original design context. The development of the John Deere D began during a period when American agriculture was undergoing rapid expansion. The early 1920s brought increasing demand for machines capable of operating on large tracts of land with minimal mechanical intervention. Manufacturers needed tractors that could handle long working cycles, inconsistent fuel quality, and the vast, uninterrupted fields of the Midwest. The Model D emerged as the company's response to these requirements. Introduced in 1923, the tractor was built around a large two-cylinder horizontal engine, a configuration that favored low-speed torque and steady combustion over high rotational speed. This was a deliberate engineering decision. American farmers valued the ability to pull heavy implements for extended periods rather than achieving narrowband mechanical efficiency. The D's engine, with its slow, powerful firing impulses, produced the type of consistent traction necessary for deep plowing on heavy soils found throughout states such as Nebraska and Iowa. The mechanical layout followed the same logic. The chassis used heavy cast iron components to reduce structural flex under load. The cooling system relied on a thermosiphon design, eliminating pumps and reducing the number of moving parts that could fail during prolonged operation. The transmission offered a small number of gear ratios, but each was designed to deliver usable torque rather than fine control. This approach minimized the mechanical complexity and made the tractor easier to maintain in remote rural areas. Fuel compatibility also played a significant role in the tractor's engineering. Many farms at the time relied on distillate or low-grade fuels, so the combustion chamber, ignition system, and carburetor were built to tolerate impurities more effectively than high-compression diesel engines. This characteristic later became relevant in Europe, where fuel availability varied by region and quality. Meanwhile, German engineering followed a different trajectory. Manufacturers such as Fendt emphasized compact diesel engines with precise injection systems and optimized combustion. Their tractors were designed to deliver exact control at low speeds, enabling efficient operation on smaller, irregular fields common across the German countryside. These machines often incorporated multi-stage transmissions, advanced fuel pumps, and calibrated injection timing. Their engineering aimed to achieve mechanical balance, fuel economy, and maximum output from smaller displacement engines. When the two philosophies are placed side by side, their divergence becomes clear. The Deere prioritized structural simplicity and operational longevity. The German machines prioritized fine mechanical behavior and efficiency. Each approach reflected the agricultural demands of its origin. The John Deere D, despite being older and simpler, demonstrated an unusually high tolerance for wear. The thick cylinder walls, oversized bearings, and straightforward lubrication systems were built to withstand long cycles of thermal expansion and mechanical stress. Many of these tractors continued operating for decades with only basic maintenance, which contributed to their reputation as some of the most durable machines of their era. As surplus American tractors entered European markets after the war, the Model D began appearing in farming regions where it had never been intended to operate. German farmers examining the machine noted the absence of the technical refinements they were accustomed to. No precision fuel system, limited gear selection, and a noticeably heavier frame. Yet these characteristics, initially viewed as disadvantages, contained the structural reasons behind the tractor's remarkable endurance. The comparison between these engineering cultures set the stage for practical evaluations carried out in fields across Germany. Farmers who had relied exclusively on highly refined tractors like those produced by Fendt were about to confront the capabilities of a machine designed under entirely different assumptions. When American-built tractors such as the John Deere D began appearing on European farms, the first evaluations were practical rather than theoretical. Farmers placed them directly into standard field operations to assess how the machines behaved under the same workload as the local equipment. These tests revealed differences not only in engineering philosophy but also in long-term operational behavior. The Fendt tractors commonly used in Germany during this period were optimized for precise power delivery. Their diesel engines produced consistent torque through finely calibrated injection systems, and their transmissions offered multiple gear ratios to maintain ideal engine speed for each task. These features enabled controlled performance in plowing, cultivating, and transport work. Fuel consumption was predictable, and maintenance routines followed established schedules. The John Deere D approached each of these tasks differently. The tractor relied on the wide firing pulses of its large two-cylinder engine to generate traction at very low engine speeds. In field conditions, this resulted in a steady pulling force with minimal need for gear changes. On heavy clay soils, the D's simple torque characteristics allowed it to maintain motion even when draft forces fluctuated, while the machine's significant weight helped keep the rear wheels anchored. Although the D lacked the refined throttle response of its German counterparts, farmers observed that it delivered a continuous and undramatic output. The tractor did not excel at rapid adjustments, but it performed consistently when the load remained high. During extended plowing sessions, this trait became particularly noticeable. Whereas precision engines required careful monitoring of overheating, injection timing, and fuel quality, the D continued to run at low speeds with minimal variation in temperature or sound. Operational endurance became the most distinctive aspect of the comparison. In many farms across southern Germany, workers conducted full-day evaluations involving long plowing stretches, belt-driven stationary work, and transport runs. The Fendt machines maintained high efficiency, especially when fuel quality was controlled and field conditions were uniform. The D, however, showed minimal performance degradation after many consecutive hours, where characteristics also differed significantly. German tractors required routine adjustments to injection systems, valve clearances, and governor mechanisms. The Deere's simpler engine architecture contained fewer components for fine adjustment, reducing the cumulative impact of long-term mechanical drift. Even after several hours of continuous operation, the D's cylinder temperatures remained within predictable ranges, supported by its low-speed combustion cycle and thermosiphon cooling. Another point frequently noted during practical comparisons was the tractor's ability to tolerate low-grade fuels. While not ideal for performance, these fuels did not cause significant operational problems for the D. Conversely, fuel quality variations caused noticeable differences in the behavior of high-compression diesel engines used in many European tractors. Soil compaction tests produced mixed results. The D's higher weight increased compaction on wet soils but provided traction advantages on dry or semi-hard surfaces. Fendt machines, designed to be lighter and more agile, performed better on soft terrain but occasionally required additional passes or weight adjustments to achieve the same draft performance. Maintenance intervals provided one of the clearest demonstrations of the Deere's resilience. After extended field evaluations, lubrication checks showed predictable wear patterns, and cooling system inspections revealed minimal scaling or pump-related issues due to the absence of moving parts in the cooling circuit. German tractors, while highly reliable, depended on more complex components that required periodic calibration to maintain peak efficiency. These field experiences gradually shifted perceptions among farmers. Although the Deere did not outperform German machines in precision or fuel economy, its consistent behavior under prolonged workloads established a reputation for durability that contradicted early skepticism. It was not designed to be sophisticated, it was designed to endure. The long-term legacy of the John Deere D is best understood as the cumulative result of decades of consistent field performance. While the tractor did not introduce advanced mechanical innovations, its endurance-oriented engineering philosophy influenced agricultural machinery far beyond the American Midwest. In Germany, the unexpected resilience of the D forced a re-evaluation of assumptions about what constituted durability in tractor design. As the tractor continued operating reliably even after many years of service, German farmers began to recognize that longevity could be achieved through multiple engineering paths. Precision design, as exemplified by Fendt, excelled in efficiency, control, and refined mechanical output. The Deere demonstrated that a different set of priorities, structural over-engineering, simplified systems, and wide safety margins, could produce machines capable of performing for decades with minimal intervention. This comparison contributed to several shifts in European tractor development. Manufacturers increasingly considered long-duration thermal behavior, tolerance to variable fuel quality, and simplification of maintenance procedures. Although European engines remained far more advanced in combustion efficiency, design teams began integrating features that improved resilience in demanding conditions. The influence was not direct but conceptual. The Deere had shown what long service life looked like in practice. The Model D's structural characteristics also left a mark. Its heavy cast-iron frame, oversized bearings, and low-speed engine operation demonstrated how stress distribution effects were patterns. Later European tractors incorporated stronger driveline components, redesigned engine mounts, and more robust gear housings. The objective was not to replicate the American approach but to integrate the advantages of structural durability with existing engineering refinement. In historical terms, the D became one of the longest produced tractors in the world, remaining in production until 1953. This longevity reinforced its reputation in foreign markets, where used models continued to work on fields long after more modern tractors were introduced. Even when newer designs offered better fuel economy or more advanced hydraulics, the D often remained in service because it provided a consistent and predictable output. German agricultural archives document multiple cases in which D-series tractors remained operational for several decades with only routine maintenance. Their engines tolerated slow degradation without sudden failure, and their transmissions rarely required complex repairs. This contrasted with some precision-engineered machines that, while more efficient, needed specialized adjustments to maintain optimal performance. The broader significance of this comparison lies in how it highlighted two complementary ideas of agricultural progress. German tractors represented optimized engineering tailored to European agricultural patterns. American machines like the D represented rugged design aimed at extreme longevity. Over time, both philosophies influenced global tractor development, contributing to the more balanced designs seen in later decades. The presence of the John Deere D on German soil also introduced many farmers to American agricultural culture. The tractor served as an example of how machinery could be built to handle vast operational times without relying on extensive mechanical support networks. This perspective expanded the understanding of what an agricultural machine could achieve under conditions of limited maintenance infrastructure. Today, surviving Model D tractors continue to be used in limited capacities, often maintained by enthusiasts or preserved in collections. Their long service life stands as empirical evidence of their endurance-oriented engineering. Meanwhile, Fendt and other German manufacturers have maintained their leadership in precision-driven designs, producing some of the most technologically advanced tractors in the world. In retrospect, the comparison between the D and its German counterparts did more than resolve which tractor performed better under specific conditions. It revealed how different engineering priorities can excel in different environments. The Deere's endurance challenged assumptions, reshaped expectations, and left a legacy defined not by innovation but by consistency. This legacy remains relevant because it demonstrates a principle that transcends national engineering cultures. Reliability can be achieved through refinement or through robustness, and both approaches contribute to agricultural progress.